Gentlemen, to lesson 3.2, I can estimate square roots, starting on page 148 of your Glencoe Course 3 textbook. Make sure you take notes, recording your vocabulary, and mark down where you have questions. So you need to know your perfect squares to be able to estimate the square roots and non-perfect squares. So somewhere, make sure you have a list of, 1 squared is 1, 2 squared is 4, 3 squared is 9, so on and so forth. Okay, make sure you have that list, and I would have it on all study guides and notes. Estimating the square root of 83. We say estimate for the ones that we know are not perfect squares. So 83 is not a perfect square, but we do know that the largest perfect square less than 83 is 81. The square root of 81 is 9. We know that the smallest perfect square greater than 83 is 100. Square root of 100 is 10. So what we decide from that, we looked at what's around 83, and that's 81 and 100. So we put them on a number line, and we estimate. Square root of 81, square root of 100. 83 is far closer to 81, so we say that it's closer to 9. So it's closer to 81 than 100. So the best whole number estimate for square root of 83 is 9. Obviously, it's going to be a little bit more than 9. It's going to be 9 point something if you plug it in the calculator. But it's closer to 81 than it is to 100. So it's closer to the whole number 9. Try the same thing here. If we estimate the square root of 83.5 to the nearest whole number, well, the perfect squares I know are that the lowest one, the one below it, is 16. Square root of 16 is 4. Perfect square above it is 25. Square root of 25 is 5. So we know that the square root of 23.5 will be between 4 and 5. So it's between 4 and 5, and on a number line, 23.5 is closer to 25 than it is to 4. So that means the best estimate whole number is that you would round it to 5. It's going to be 4 point something, but it's going to be closer to 5 than it is to 4. So try some of these. I know that the smallest square on a number line next to 35 is 25. This is kind of how I show my work. And the one above it is 36. So I look and I see, oh, this is 10 away, whereas this is 1 away. So on a number line, is the square root of 35 going to be closer to 5 or to 6? Since it's only 1 away from 36 and 10 away from 25, I know it's going to be far closer to 36. So rounding to the nearest whole number, like my directions say, the square root of 35 is closer to 6. 44 and 8/10. So I decide what's on either side of that, and I'm drawing with my mouse right now, so please be patient. So the perfect square that's larger than that, I know, is 49, which has a square root of 7. Below that is 36, the square root of 6. So I see which 44 and 8/10 is about 8 and 8/10 away from 36, whereas it's only 4 and 2/10 away from here. So it's closer to 49. So it's closer to 7. Square root of 170. So I find out is that in between? Making your predictions. I know it's less than 196. And I know it's more than 169. Those are my perfect squares. And these are a little bit more tricky. You would want to look, try them. You know it's more than 10, 10 times 10. And using your perfect squares, I know square root of 169 is 13. Square root of 196 is 14. 169 and 170 are only 1 away, whereas these are 26 away. So the whole number closest to the square root of 170 is 13. Another one to try, a word problem. Give it a try and then come back. It says the golden rectangle is found frequently in the nautilus shell. The length of the longer side is divided by the length of the shorter side is equal to 1 plus the square root of 5 divided by 2. Estimate the value. So what we're going to do is first we're going to estimate the value of the square root of 5. Well, we know that it's between 2 squared, which is 4, and 3 squared, which is 9. So it's going to be between the numbers of 2 and 3. So 4 and 9 are perfect close squares. These are square roots, and simplify. So that was a lot more work than we might have done, but we know that it's between 4. So if you kind of show it like this, that might help right away. And you realize that gets you to 2, and that gets you to 3. So it's going to be between 2 and 3. But we're not done. So if we estimate it, we plug it in, it's closer to 2, because 4 is closer to 5 than 9 is. It's close to 2, it's approximately. Notice how we did approximately, because it's not exact since we rounded. It's approximately 1 plus 2 over 2, which is 3 over 2, which is 1 1/2. So, a little bit of a quicker one for you. Make sure you know your perfect squares and you have that chart. Rewatch, go to examples in your book, personal tutor, and other resources. You have so many, so make sure you are taking advantage of those. Good luck.